Okay, so we move on to our last example here. This is the one where I said it's okay to scream. So you want to pause the video and scream, or if you want to scream along with me, ah, then you can. All right, this is going to be a little bit of work. Now, when we're faced with this situation where the power on the tangent is even and the power on the secant's odd, that means I can't pull off a secant squared and have a secant squared stuff left to transform it in tangent. I can't pull just a tangent and a secant off and then convert the remaining tangents over to secants. Right? I'm not able to do either of those. So because secant's odd, the only thing I can do is take my tangents and turn them into secants, so that I'm going to have a big old integral in terms of secants. So that's what I do. It's the only thing I can do, so that's what I do. So tangent is secant squared minus 1. And that's times the secant cubed. So multiplying through, we would get integral of secant to the 5th x minus secant to the 3rd x dx. And so now we're ready to start using our reduction formulas. So much like we had to do in both sine and cosine, have only even powers. When that's the case, then you had to convert them either into sines or cosines and work the problem out with the reduction formula. That's the same thing here. That's what we're doing with here, except this one we only have the one option. We have to turn the tangents into secants. Okay. So since our reduction formulas go down in order, a 5th power one will be in terms of a 3rd power one. Let's go ahead and work out the 3rd power one first. So integral of secant cubed x dx. So let's go back up and just refer to our reduction formula first of all. Reduction formula for secant. There he is. Secant to the n power becomes secant of 2 powers lower times tangent divided by 1 power lower plus fraction n minus 2 over n minus 1 integral of secant n minus 2. Okay, so let's apply that here with the cube. The cube would drop it by 2, which would make it go from 3 to 1. So you'd actually have secant tangent over 3 minus 1, which is 2. So secant tangent over 2. And then plus n minus 2 over n minus 1, that would actually be 1 over 2. All right, and then integral of secant to the 1st power. Okay, so let's go back and write down that information. So this is again going to be secant 2 powers lower tangent over n minus 1, 3 minus 1, plus n minus 1, n minus 2 over n minus 1, integral of secant 2 powers lower. And remember, secant x, the integral, we can do that one. So this is going to be secant x tangent x over 2 plus 1/2 ln absolute value of secant x plus tangent x plus a constant. Okay, and so again, this piece, oops, I forgot to close my absolute value. Okay. So this piece here, we're going to come back to, because when we do the reduction formula on secant to the 5th, we will need a secant cubed for that piece as well. So we're going to have to work that out. Okay, that's our secant cubed. And now we're going to take our secant to the 5th. And also remember this stuff here, when we put it back together later on, is going to be subtracted. So we do have to remember the subtracting off of this stuff later on when we do the problem. Okay, so that's just something to keep in mind a little bit later on. Okay, but I don't think it will matter. Actually, I'm looking at what I'm planning to do here. It's actually not going to matter. I'm going to take care of that in the problem a little bit later here. Okay, so but we will come back to that. So let's go to our secant to the fifth in the reduction formula. Integral of secant to the fifth x dx, again, is secant of 2 powers lower. So that would be secant cubed times the tangent divided by n minus 1. So in this case, 4 plus n minus 2 over n minus 1 integral of secant cubed x. Okay. But remember, the whole integral, secant to the fifth minus secant cubed, would actually be just this stuff, secant cubed x, tangent x over 4, plus 3/4 integral of secant cubed x dx, got my little dx here, minus the integral of secant cubed x dx. In other words, it will just be secant cubed x tangent x over 4 minus 1/4 the integral of secant cubed. And then I can put on my result from the integral of secant cubed. Right, because I'm just combining those two integrals together. That's minus 1/4 the integral of secant cubed, which is just that stuff. Put that in, simplify and combine whatever we can combine, which I don't think is going to be much of anything. So secant x tangent x over 2 plus 1/2 ln absolute value secant x plus tangent x. Of course, close that and don't forget about our plus c. So putting it all together to finish things off, secant cubed x tangent x over 4 minus secant x tangent x over 8 minus 1/8 ln absolute value of secant x plus tangent x, and then finally plus our constant. Okay, now we can kind of relax and maybe kind of understand why I said when we see this, let's just scream. Right? Let's just scream, because the other ones are pretty straightforward mostly, but this one, not so much. Not so much. Okay, so we had to use a reduction formula twice there. Once for secant to the fifth and once for secant cubed, and then I put them all together. Okay, so there we go. And that wraps up this long section on trigonometric integrals. One thing you might have noticed, I didn't do integrals with cotangent and cosecant. There are reduction formulas for cosecant and cotangent. A lot of the rules and setup ideas that we used here with tangent and secant to be able to work out our integrals, the same kind of things come into play with cotangent and cosecant. It's just kind of mostly a mirror image and they have their own reduction formulas for when you're faced with either just powers of a tangent or powers of a secant. So they would have a similar thing if you ran into those. So, so if you happen to run into those at some point in the future in some other class, then you would just have to refer back to, look up some formulas for reduction formulas. The other ones, like I said, would work very similar on the basis of, a similar set of relationships for cotangent, cosecant. But we're not going to deal with those at all in this class, so we're not going to worry about it. If you're doing tangent and secants enough, cotangent, cosecant's close enough to that. If you ever run into it, you can kind of rely back on the ideas from here if you needed to do that in some other course for some other topic sometime in the future.